want you to know that it's our time. You and me bleed the same light. I want you to know that I'm all yours.
What is going on, ladies and gentlemen, and welcome to a video relating physics in video games to physics in real life, specifically in CSGO. For those of you that don't know what CSGO is, it is a first-person PC shooting game, multiplayer based, that was created on August 21st, 2012, and is one of the biggest esports related video games on the market currently. In this video today, we'll be talking about jumping and throwing grenades, jumping and sniping, bunny hopping, a surf mechanism, and long jumping. In CSGO, there are multiple tacticals that can be thrown throughout the game, including grenades, flashbangs, smoke grenades, decoys, and molotovs. For this specific representation, we will be using decoys though. Also in CSGO, when throwing a tactical, there are multiple ways you can throw them. There's a short way, a long way, and then there's like an in-between medium way. In this representation, we'll be throwing the decoy in all three modes and comparing the angles and initial velocities. So as you can see here, all of the starting angles are the same, but the initial velocities are much different. The lowest mode goes very short distances, the medium mode goes, a medium distance, and the longer mode goes a much longer distance. This is due to the difference in initial velocity in the X direction. In this video clip, we will be comparing a throwing of a tactical when jumping versus when falling. So as you can see here, we just jumped and threw one, and then the second one we were falling when we threw it. When you're jumping and going in an up direction, that actually gives you a higher initial velocity in the Y direction, which therefore makes your tactical fly further. When you have a lower initial Y velocity when you're falling, that causes the tactical to go slower. Over here we have a very good representation of how this is used in esports play. So they will jump and throw a grenade up into this little bomb area up here to check to see if there's anybody there, and as you can see, if you do it while falling, it doesn't exactly work. In this representation, we will be showing how jump sniping is working in this game and how it affects accuracy while sniping. So as you can see here, we toss a just another decoy to show the parabolic motion. So at the top of your parabolic motion when jumping, your initial or your velocity in the Y direction should be 0. So this therefore affects sniping. Your sniper scope will steady out. So as you can see in this representation, we are jumping, and at the peak we are shooting. And those dots, the blue and red dots, represent where we are hitting. So now as we jump and snipe while moving in the upwards direction, it is much more inaccurate than when we are at the peak of our flight, I guess you can say. Recoil in this game works very similarly to how it does in real life. When the bullet leaves the chamber, the gun pushes back on your body, just as a Newton's third law pair would do. So as you can tell, the M4 has a pretty static recoil pattern as opposed to the AK. The AK is a more powerful weapon, therefore the weapon would be kicking more because it has more power behind it. Recoil can be controlled in this game just by simply aiming your cursor down and dragging it down as your gun is trying to push up. Now over to something that actually does not follow the rules of physics in CSGO. This is called bunny hopping. Bunny hopping is when you just constantly are holding down the spacebar and you are constantly jumping, but you can turn in midair while jumping, and as we all know, this is not possible. Here's an example of what the character model looks like while bunny hopping. As you can see, he's basically side strafing and jumping sideways, which is, as we all know, physically impossible. Here's another example of something that is physically impossible that is in this game. So on these custom made maps, there is a movement system called surfing. As you can see, is named surfing because we are basically sliding or surfing alongside of these panels here, and it's basically like, you know, we're just traveling a couple of thousand meters per second, you know, just sliding down this thing. So basically, this game mechanic is just not realistic whatsoever. Here's a little extra bonus clip from another YouTuber who actually has explained this whole ostrich effect and peeker's advantage to a T, and it is something very interesting that relates to the competitive scene of CSGO.
So you can be wary of where your player model is, when you can see an enemy, and when an enemy can see you. The first question to ask is, where is the player's camera? Where are the player's eyes? Now you might say on either side of the player's nose, but that's just the model and you're a smart. In video games, there's a specific point that defines where the player's camera is, or where their view is. To find it, we go to our test map. Walking along the border of this slope, I stop when the top plane looks completely flat to me. That height is where my camera is. You can see how the fancy orange squares in the texture line up at this point, to 4 squares tall. Each of the squares is exactly 16 units by 16 units, so the player's camera is 64 units tall. I love square numbers. How elegant. Having a player stand at this height, we can see that the camera does indeed come out of the player's head, but depending on the animation. Some weapons cause the player to lean forward more, making the camera come out of his forehead. But some have the player more upright, with the camera coming out of his chin. This also depends on what side you're on. For example, terrorists lean forward when knifing, making them shorter and more difficult to hit from behind. Whereas counter-terrorists do not, they stand upright. It's difficult to keep mindful of all of these little nuances. Wait a minute, I can shoot over the thing. That means that when we shoot, the bullets come out of the player's camera, his eyes, and not his gun. Talk about a piercing gaze. This means when you can see an enemy's face, they can shoot you, regardless of where their gun is. Now let's talk about corners. One thing you'll experience many times every single round is trying to shoot an enemy around a corner. The question is, who is visible first, and how can you manipulate your movement and position to give yourself the advantage? The first thing you need to think about is, am I visible? Remember that the camera comes from a single point. There's all this manly bulk around the sides, meaning that sometimes, even though you can't see them, they can see you. Some players get really frustrated, wondering how a player saw them and claim that there's some kind of cheating going on. This is what is called the ostrich effect. The ostrich is so stupid, it will stick its head in the sand, thinking that if it can't see you, you can't see it. Don't be an ostrich, continue watching this tutorial.
So that pretty much wraps it up for our video today. I hope you have a little more understanding of how the physics world in CSGO works, and we'll see you guys later.